In this example, we're going to look briefly at how to factor a sum of squares. Now you might be saying, oh, a sum of squares, I've been told that's not factorable. Well, that's true, it's not factorable in the real number system, but if we open things up a little bit into the complex number system, where we can include the imaginary numbers, cat, stop, go away, sorry, my cat felt like scratching my chair. We open that up to the complex number system, we can actually factor a sum of squares, and the formula for so would look something like this. The sum of squares, a squared plus b squared, would actually factor as a plus bi times a minus bi. So it's just like the difference of squares, but this second factor, the second term in each factor has the imaginary unit I as part of it as well. I can go ahead and multiply this out just to show that it does produce what we started with, just for a little exercise with that. So if we tried to distribute this all the way out, a times a would equal a squared. And then a times negative bi would be negative abi. Positive bi times a would be positive abi. And finally, positive bi times negative bi would be negative b squared I squared. You got to know a little bit about your exponent rules to kind of follow what I was doing there. But now going ahead and simplifying this a bit, these two terms here in the middle cancel each other out, the positive abi and the negative abi. And that just leaves me with a squared. And then over here, we have minus b squared I squared. But remember, I squared is negative 1. And then if we multiply this negative b squared times negative 1 right there, that would actually make it become plus b squared. And you can see we did, in fact, arrive at what we originally had. So we've derived a formula here, or I guess we've verified a formula here. We didn't derive it. We verified a formula here for factoring a sum of squares using the imaginary unit I. So I'm going to go ahead and do an example now using that formula. So if I had a sum of two perfect squares like this, and I asked you to factor, maybe I had x squared plus 36, like that, and I wanted to factor that. In the real number system, like I said, that's impossible. But now that we've opened this up to the complex number system and we can use this imaginary unit I, we should be able to factor this as x plus 6i times x minus 6i. If that had been a difference of squares, if that had said x squared minus 36, it would look just the same as this, except the i's wouldn't be there. So it's just a slight little twist for factoring the sum of squares from what you've already learned about factoring differences of squares earlier on. Hopefully that's helpful. Until next time.